Hi everyone, and welcome to everybody new that has just joined up. In a recent YouTube video, I displayed the curve tracer troubleshooting a circuit inside a Sansui amplifier, and this has attracted a lot of attention to the curve tracer again. So this has prompted me to go back through my recent curve tracer videos and see if I can add anything to those videos to make your troubleshooting procedure just a little bit easier. And there are a few things that I can add, and one of them is testing a MOSFET out of circuit. I also didn't display testing a PNP transistor, so we'll take a look at that and a few other things as well. So I have a small schematic drawn up, and I'm going to put this stuff on a breadboard. This stuff is very easy. You can even build this into a little test fixture if you want to compare transistors and FETs and things like that on the curve tracer. I plan in the future to create an automatic switch box. So the switch box will move between devices. So if you want to compare things on the actual curve tracer, you can see, watch each one move back and forth. There'll be a little LED beside each component, and you can see which one is different. Or if you want to say match transistors, or if you want to match FETs or anything like that, it'd be really, really handy to have that thing on the bench. So I've got a lot of really neat projects planned here for the future, and as all of you know that have been here for a while, it's now getting into the winter season, and that allows me some more bench time. So when I'm at the bench, I design things and release them to you guys here on Patreon. So I got a lot of really neat things coming, lots of ideas rolling around. Right now, I'm really excited to get that Vitalizer done so I can get onto these projects. So anyways, I'll get a schematic here on the bench, and I'll show you exactly how to hook a transistor and a FET up to the curve tracer and test it. I'm ready to test a PNP transistor with this test fixture right now, and as you can see, I've been limit testing some components. So it's a really easy setup. You just need a couple of components. You need a 100k ohm VR, a 1k ohm resistor, a bunch of jumper leads, and a split supply. If you don't have a split supply, 2 9-volt batteries will work just fine. So this is the schematic for it. So assuming that you do have a split supply, you'd adjust the split supply to positive and negative 9 volts. You'd take the center and attach it to the common lead on the curve tracer. So we'll take a look at the curve tracer here. So this is a common lead right here on the curve tracer, and as you can see, I've got this green boot attached to it. This runs over right over here onto this test fixture to the collector of the PNP transistor. So you basically just put this in place of this NPN transistor here in circuit. So the red lead on the curve tracer, this lead right here, is attached to the emitter of this PNP transistor. The 1K resistor, the center or the wiper of this VR through the 1K resistor attaches to the base, and this can just be left in circuit like this. So this will always attach to the base or gate of the FETs. The reason that we need a split supply here, so technically the center of this VR would be considered just ground. The reason we need a split supply is if we're going to test PNP transistors, we need a negative 9-volt supply. And if we're going to test NPN transistors, we need a positive 9-volt supply. That's the same for N or P channel FETs as well. So by putting a 100k ohm VR here, we can sweep all the way from positive 9 volts all the way through ground, all the way to negative 9 volts, all with just one component here. So it makes things quite handy. So if we take a look at the curve tracer here, I'll just rotate the VR here. And if we take a look at the curve tracer, you can see that I'm turning this transistor on. And as I rotate this and come to this point right here, the transistor is fully on. Now, if I rotate the VR the opposite way again, I can slowly shut off that transistor, and as you can see, it's slowly shutting off until I get a flat line right there. So whenever you see a line like this on the oscilloscope like this, it basically means an open connection. So for example, I'll just remove the red lead here, and as you can see, there's no connection to it right now. And then if I rotate this, basically the transistor is turning on. It's in a resistive state right now. It's in the linear region, if you would like to call it that. As I rotate this and bring this negative, So the base is going to have, negative 0.6 of a volt or so on it right now. You can see that the transistor is fully on, so it's acting like a switch. So basically on, off, on, off. And you can compare transistors with this as well. So just say you had a test fixture and you have two of these transistors, and say you rotate the control to this point right here. All right, so we're kind of in the middle of being on and off with this transistor, right? Partially on, we'll call it that. If you were to, say, switch to another transistor, so say that the test fixture is going back and forth between transistors, so one transistor looks like this, one transistor looks like this, one transistor, as it's going back and forth, you can see that the transistors wouldn't be matched. So this would be, in a case that this transistor would be turned on more, and this one here would be more in an off state. So you can use this to compare transistors very closely as basically as the test fixture is moving back and forth between components. So as you can see, very, very handy to use. You can do this with small signal transistors and really large transistors. Really, really easy to do. In the previous video, which I'll link below this video, so there's a bunch of curve tracer videos that were done in the past. I'll link them below, so just click on the link and it'll take you directly to the video. You'll see me testing NPN transistors and things like that. One thing I didn't show you is how to test an N-channel FET. So what I'll do next here is I'll put an N-channel FET in the test fixture here, and we'll take a look at what it looks like as we slowly turn it on. I have an N-channel FET in the test fixture now. It's this IRF 520N. And I've also added a capacitor across this device just because it's so sensitive. I want to keep any noise out of the circuit. So what I've done is I've taken a capacitor from this point here that attaches to the gate and just run it down to this lead here, and it keeps the circuit nice and quiet. Now, depending on your test fixture and the way that you build it, you may not need a value like that. This is 0.1 microfarad. You may not need a value like that to keep things quiet. But again, this is all exposed. Look at all these wires all over the place and everything, right? So it's going to pick up noise. So in order to plug the FET into the test fixture, it's pretty much the same as an NPN transistor. So the drain would go to where the collector normally would, to the red lead of the curve tracer. The FET source would go to the black lead, or where the emitter normally is on an NPN transistor. And the gate is always attached to where the base would normally be. So whether it's an NPN, PNP, N-channel FET, P-channel FET, it's always attached at this point here. So this is always attached to either the gate or the base of the transistor. And again, you can put a 0.1 microfarad capacitor across this to ground just to keep the circuit quiet if you like. I've got a voltmeter attached to the gate of this FET right now. So it's from the gate, from this point here, down to the ground, so that we can actually take a look at the gate volts to turn on this FET. So if we take a look at the curve tracer now, you'll see on the screen what looks to be like a diode. Well, we're looking into the device right now, and we're seeing this diode inside the FET. That's what we're seeing right now. So if you ever hook this thing, the curve tracer, across an NPN transistor and you see this, or you see what you see on the screen here, that means that inside that NPN transistor, there is a diode as well. And that's really common in switching transistors and, like horizontal deflection transistors and things like that. A lot of the times they'll have a diode in them. So that's what we're seeing. So what I'm going to do now is I'm going to slowly rotate this VR, and we'll watch the curve tracer screen here, and we'll see this slowly turn on. So it'll slowly turn to a vertical line again. Here we go. It's already starting. And if we look at the voltmeter, it's 2.1 volts right now, and it's just starting. So I'll just keep advancing this, and it very quickly turns on. Right there, it's, I would say, fully on. It's about 3.8 volts. So comfortably 4 volts, and this FET is completely on. So you can see that right now, this FET would be in its resistive region right now. So if we wanted to use this as a resistor of some sort, it's a very tight region. So it starts to move, we'll say right there. So about 1.6 volts, and then it quickly comes in. See, I'll move this slowly. It quickly comes in at about 2 and a bit volts, and then it rises really fast. I'm just ever so slightly turning this potentiometer right now. And you can see, bam, right there it's on. So that FET is on. So 3.6 volts it seems to be in, safely 3.8 to 4 volts. I would want to have this to make sure this FET is fully on. And that's how easy it is to test a FET. So right now we're looking at the diode inside, and right now we're actually watching it turn on and off. Just that easy. We can check all of that stuff with this curve tracer. The next FET that we're going to test is a 2N5486. So that's this little fellow right here. This is an N-channel small signal transistor, and this is also known as a depletion style FET. So when I say depletion, that means that when the gate voltage is at 0, it's actually on. So you need to bring the gate voltage negative in order to shut this little fella off. And as you can see right now, we're at negative 9.2 volts. So we'll take a look at the curve tracer here in just a moment. So the last FET that we tested is known as an enhancement type FET. So that means at 0 gate volts, the FET is off. So you bring it positive to about 3 or 4 volts and the FET turns on. And depending on the type of FET, sometimes they turn on a little bit earlier as well. So this is a depletion style FET. The last FET that we tested is an enhancement style FET. So we'll take a look at the curve tracer here. And as you can see, nice, clean, flat line. So I'll adjust the VR here. So I'll bring it positive. And as you can see, right there, the FET is on. Now, depending on the on resistance of the FET, it might not be a straight line right up and down. It might be a little bit on an angle. This shows that it is in the resistive region. You'll notice in a lot of switches, like say 4066 is a pretty common IC switch. You'll notice that the on resistance of something like that is actually pretty high in the ohms. So it's not necessarily, right down to 0 ohms when they're on. It just depends on the type of FET. So as you can see here, it's on and then off. So technically at 0 volts. So when you get to 0 volts, it's tough to get the meter right on 0 volts, but that's considered when it's on. We're actually over 0 just a little bit. And that's how you would test a depletion style FET. Just that easy. Just plug it in and away you go. So you can see there's no diode or anything in this thing. It's just a nice clean FET. Very commonly used as variable resistors in, automatic gain control systems and things like that. Limiters, circuitry like that. The 2N5486 is a great N-channel FET, and it's the FET that we're going to use in the Active Probe project coming up here very soon. So I've got quite a few of these things, surface mount and through hole, and I'll build 2 versions to share with you guys. And believe me, having an active probe on the bench is very, very handy, well, as you've seen in the last video. Another nice feature of this curve tracer is you can test LEDs in circuit and you don't need to worry about which way you attach the probes. It'll light the LED either way. So whether you have the probes like this or like this, it'll light the LED up just fine. Now, this is a bicolor LED, so there's 2 colors in here, red and green, so it'll give you a good example of lighting up an LED in this direction and an LED in this direction. So I'll just attach these here. And we'll take a look at the curve tracer. Now what I'll do is I'll turn the sensitivity of the curve tracer way up. That circle is for me holding the LED here. I'll just let go of that. So I'll turn the curve tracer up here and you'll start to see a curve. This curve right here, you see how this is curving first? This side here would be the green LED and this would be the red LED. How do I know that? Well, the red LED has a lower forward voltage than the green one, so it's going to come on first. So if I keep advancing this, you'll start to see a little bit of a red glow in there. See how it's starting to glow red? Now this here is the green LED. So if I keep advancing this, you'll start to see the green side light up as well. So I'll turn the sensitivity down on the machine here. So you can see that. So if I turn this down, if we look at the LED, you'll see the green one goes out first because it has a higher forward, and the red one is still glowing in there. Now on the screen, you can see that they're both still on. It's just that this is so sensitive, it's actually showing that they're starting to work before they're even showing any type of light. So I'll just turn that right down. And as you can see, it's pretty much not glowing. But if we turn the sensitivity up, we can definitely see that it's still trying to be on. So right about there, it's starting to turn on as it turns the corner. I'll turn the sensitivity down. And we can start to see that red glow. If we look at the other side, We can see that it's trying to turn on as well. And we can see the green glow now. So the reason it's lighting both of these up is because it's an AC signal. So basically what it's doing is the current is flowing this way, and then this way, and then this way, and then this way. So basically it's turning on one LED because one LED faces this way and the other one faces this way. So we get both LEDs lit up at the same time. That's really handy for testing LEDs in circuit. This thing is current limited, right? The Curve Tracer is current limited, so it makes testing LEDs in circuit really quite safe, especially when they're attached to an IC or something like that. So as you can see, there's so many uses for this Curve Tracer, and I'm sure over time I'll just go, oh, I should have told them about this one too. You know, they just keep, you know, popping up. So this is a few other things that I just didn't explain in the original video because there's just so many things. You know, I could keep going on and on and on about this Curve Tracer. And the nice thing about the Curve Tracer is it's like playing a game. Like say you're good at billiards. The more you play pool or the more you play billiards, the better you get at the game. And it's the same thing with the Curve Tracer. The more you use the Curve Tracer, the better you get at using it. You start to understand what you see on the screen, and you'll start to go, oh, okay, I recognize this. This looks like, you know, a Zener diode. Or you'll start to see capacitance in there. So what I'll do is I'll just turn this down here. Actually, I'll take this out of here and I'll put a capacitor across it and show you what a capacitor looks like. This is in the first video. So, you know, like, here's an idea of, you know, what a capacitor looks like, right? So you can start to recognize capacitance, you know, by the circle on the screen. And, you know, as resistance changes, you know, if this capacitor was leaky, it would start to tilt, things like that. So again, you know, the more you use the Curve Tracer, the better you'll get with it. And, you know, you'll find yourself finding problems in ICs just as quickly as I did in that Sansui. And I have a lot more videos coming with this Curve Tracer. It really is such a good device. I use it all the time. You don't see me using it much on camera because not many people have these things. So I try to use test equipment that more people have so that way they can feel comfortable with troubleshooting. But really, this, you know, device is absolutely indispensable. This has found the most in-depth problems. Noisy Zener diodes in circuits that would just not normally be detected, intermittent faults, and all sorts of very interesting things. So I hope you've enjoyed this episode. Definitely check out the other links that will be in the description below this. I'll link in the earlier videos to this Curve Tracer to make them just a little bit easier for you to find. And have fun building. If you have any questions, feel free to put them in the comments below and I will try to address them. If you enjoyed the video, you can let me know by clicking the little heart symbol below, and I'll see you next time. Bye for now.